Welcome back everyone. Today we are going to discuss the topic of vitamin B2. This vitamin B2 which is also known as riboflavin. Vitamin B2 is also known as riboflavin. Riboflavin is also called as the yellow enzyme or Warburg enzyme. Yellow enzyme or Warburg enzyme. This vitamin B2 is the first B complex to be isolated in pure state. So this is the fact we need to remember, that B2 is the first B complex to be isolated in pure state. As the name suggests, it's also called yellow enzyme. It gives yellow color to the urine. It gives yellow color to the urine. Another fact is that it's a redox vitamin. Why it's called redox vitamin? Further down we are going to see. For now, remember it's FAD, that is flavin adenine dinucleotide, is a part of electron transport chain, ETC. This FAD is a part of the ETC as a redox couple. It's called redox vitamin because FAD is a part of the electron transport chain as a redox couple. This vitamin is light sensitive vitamin, and this also is heat resistant vitamin. So B2 is light sensitive as well as heat resistant. Now we are going to see some sources of B2. There are three major forms of B2 that are lactoflavin. As the name suggests, lacto, it's from milk. The next is hepatoflavin. As the name suggests, hepato, it's from liver. And also ovoflavin, chief source is eggs. As the name suggests, ovo, chief source is eggs. And also we get vitamin B2 from cereals and green leafy vegetables. So sources of vitamin B2 is lactoflavin from milk, hepatoflavin from liver, and ovoflavin from eggs. And apart from that, cereals and green leafy vegetables. The next we are going to see is these vitamins active form. The active form of B2 is FAD. As we discussed above, this is a part of the ETC as a redox couple. So FAD stands for flavin adenine dinucleotide. Also, the active form of this B2 is FMN. It stands for flavin mononucleotide. So the active form of B2 is FAD and FMN. FAD stands for flavin adenine dinucleotide and FMN stands for flavin mononucleotide. So now we are going to discuss one by one. First is FAD, that is flavin adenine dinucleotide. FAD is a part of acetyl coenzyme A dehydrogenase, which is involved in the first reaction of fatty acid oxidation pathway. This FAD is most importantly present in acetyl CoA dehydrogenase enzyme, which is involved in the first reaction of fatty acid oxidation pathway. Then the next example is succinate dehydrogenase, which we must be knowing is the complex 2 of ETC. This complex 2 of the electronic transport chain succinate dehydrogenase contains FAD. Next example is D-amino acid oxidase. Then we have got xanthine oxidase. Then we have got pyruvate dehydrogenase. This pyruvate dehydrogenase was also in form of P1. Next is alpha ketoglutarate dehydrogenase, which we have also seen in previous lectures, also in B1. Next is branched chain ketoacid dehydrogenase, which we have also seen is also present in B1. So these three multi-enzyme complexes, pyruvate dehydrogenase, alpha ketoglutarate dehydrogenase and branched chain keto dehydrogenase, are also present in B1, and they are common to FAD in vitamin form of B2. In B1, the active form was TPP or thiamine pyrophosphate. I hope you remember this. Apart from that, most important are the acetyl CoA dehydrogenase, fatty acid oxidation pathway, and succinate dehydrogenase, this second complex of the electron transport chain. We have discussed this form of FAD, where it is present, in which form, in which enzyme complexes. Next we are going to see is FMN, is flavin mononucleotide. It is present in the complex 1 of electron transport chain, that is NADH dehydrogenase. So complex 1 of electron transport chain, NADH dehydrogenase, contains FMN as the active form of vitamin B2. Another example is L-amino acid oxidase. L-amino acid oxidase and NADH dehydrogenase, that is complex 1 of ETC, contains FMN. Complex 2 of ETC, succinate dehydrogenase, contains FAD. So these are the two active forms of B2. We have seen the enzymes and the multi-enzyme complexes where they are present. Now we are going to discuss the most important aspect of this vitamin B2 is deficiency manifestations. Of B2. The first deficiency manifestation we see is chelosis. The First deficiency form is chelosis. Chelosis is characterized by pallor in angles of mouth. Next feature is thinning and laceration of epithelium. There is pallor in angles of mouth near the lips and thinning and laceration of epithelium. The third feature is the fissuring extends to radially to the skin. The fissuring, when extending to the skin, it extends radially. The fissuring extends radially to the skin. So this is chelosis. Chelosis represents pallor in angles of mouth, thinning and laceration of epithelium, and the fissuring extends the skin radially. The second we are going to see is glossitis. From the word itself, we are going to see it generally affects the tongue. So the tongue gets magenta colored tongue. This is the most important feature of B2 deficiency. And under this glossitis, we also see loss of papillae, which results in the tongue becomes smooth. So this papillae gets degraded and lost, which results in the tongue becoming smooth. The surface of the tongue becomes smooth and magenta colored tongue in glossitis. Third thing we are going to see how the eyes are affected. In eyes, we are going to see keratitis, conjunctivitis, photophobia, lacrimation, and circumcorneal vascularization. It is vascularization around the iris and the cornea. Out of all this, the most important feature is photophobia. This photophobia in the eyes is one important feature of B2 deficiency. As we have seen that magenta colored tongue is an important feature, is a clinically identified feature. This photophobia is also an important feature that is clinically identified. This magenta colored tongue is also clinically identified. Then we also see in the skin seborrheic dermatitis in skin. In skin, dermatitis is also seen, which is seborrheic form. The fifth is going to see in the peripheral smear normocytic, normochromic anemia in peripheral smear. Peripheral smear, the features will be normocytic and normochromic anemia. Size of the RBC and the color of the RBC are going to be normal, but there is going to be reduction in hemoglobin. So this is going to lead normocytic normochromic anemia in the peripheral smear in B2 deficiency. So we see the 5 deficiency manifestation of B2. First is key losses. Next is glossitis, in which magenta colored tongue is a clinical feature. Then in the eyes we see keratitis, conjunctivitis, photophobia, lacrimation and circumcorneal vascularization. Then in the skin we see seborrheic dermatitis, and in the peripheral smear, when blood is sent for laboratory examination, we see normocytic normochromic anemia. Next we are going to discuss is the biochemical assay of B2. So the biochemical assay of B2 requires administration of FAD, after which erythrocyte glutathione reductase activity is observed. So in the biochemical assay of B2, the patient is administered FAD. FAD in the chemical form, it is administered the erythrocyte glutathione reductase. This glutathione reductase enzyme in the erythrocyte or the RBCs. Glutathione reductase activity is observed. In another form of biochemical assay is urinary excretion of B2. So in the biochemical assay we have seen the glutathione reductase activity, erythrocyte glutathione reductase activity and urinary excretion of B2. So this is what we do in the biochemical assay of vitamin B2. Next we are going to see an important fact. There is no toxicity of vitamin B2. Often we see toxicity of vitamins and their concentration increases up to a certain level. There is no toxicity of vitamin B2. Then we are going to see RDA. Is the required dietary allowance per day. The consumption of vitamin B2 depends on carbohydrate metabolism. Just like vitamin B1, the consumption depends on the carbohydrate metabolism. And the requirements is related to calorie intake. And as we have seen in vitamin B1, consumption is also depends on carbohydrate metabolism as well as calorie intake. The RDA here is 2 to 3 milligrams per day in adults. And in pregnancy and lactation, it goes to 0.5 to 1 milligram per day. So in this RDA, we require 2 to 3 milligrams per day in adults, and during pregnancy and lactation, it's 0.5 to 1 milligram per day of vitamin B2. So this is all what you have discussed in required regarding vitamin B2. Vitamin B2 is also known as riboflavin. This flavin word is related to vitamin B2. It's called yellow enzyme or Warburg enzyme. It's the first B complex to be isolated in the pure state. This enzyme gives yellow color to the urine. It's also called redox vitamin. This is an important fact, as FAD is a part of electron transport chain as a redox couple. This vitamin B2 is light sensitive and vitamin is also heat resistance. In questions they will be giving these specific keywords: the heat resistant vitamins, this yellow color vitamin, yellow enzyme, or redox vitamin. From that we can guess that it is related to vitamin B2. And the sources are lactoflavin from milk, hepatoflavin from liver, and riboflavin from eggs. Apart from that, cereals and green leafy vegetables are also very good sources. Then we are going to discuss active form of B2. It is FAD and FMN. FAD is present in acetyl coenzyme dehydrogenase, succinate dehydrogenase. These two are the most important forms. Also N-amino acid oxidase, xanthine oxidase is also present in pyruvate dehydrogenase, alpha-ketoglutarate dehydrogenase, and branch chain ketoacid dehydrogenase, as B1 was also present. Now FMN is present in complex 1 of electron transport chain, it is NADH dehydrogenase, and is also in L-amino acid oxidase. Then we are going to see the deficiency manifestations. Deficiency manifestation include chelosis, glossitis, in the eyes keratitis, conjunctivitis, photophobia, lacrimation, circumcorneal vascularization. In the skin there is seborrheic dermatitis, and in the peripheral smear there is normocytic normochromic anemia. Out of these, most important are the glossitis, in which magenta colored tongue appears. There is pallor in angles of mouth, and there is photophobia. These are the keywords we need to remember. Then the biochemical assay, in which we first administered FAD to the patient, and then we assess the activity of erythrocyte glutathione reductase. Also we can assess by urinary excretion of vitamin B2. Generally there are toxicity of vitamins, but there is no toxicity of vitamin B2 in the RDA, as in B1 its consumption is related to carbohydrate metabolism and calorie intake. It is 2 to 3 milligrams per day in adults, and during pregnancy and lactation it goes to 0.5 to 1 milligrams per day. So this is all about vitamin B2. I hope this helps you guys. Remember to revise the topic. Thank you and good luck.